Hello, NG7M Max here for another video, and it's been a while since I've made any videos related to the RF kit, but I'm back from Hamvention 2019, actually my first time going, and a big announcement there was around RF kit coming out with a new amplifier, the RF2K -S as in Sierra. And for the US customers, they have an exclusive deal with DX Engineering. So the cool thing about the new amp, redesigned controller, it's got a onboard ARM processor, much faster than what was on the Mega controller of the B26. But the most interesting for me is that pin-diode switching. So Reinhardt worked out the details, and so the new amplifier RF2K-S has pin-diode switching, which is really cool. So the only mechanical switching on the new amplifier is going in and out of standby and to operate, and then of course the relays for the band filters and antenna tuner, I assume, too. But as far as running the amp, if you're in operate, there's no mechanical switching going on once you're on a band. So anyway, the reason I made this video is there's going to be a few of the components on the new amplifier that will be able to take advantage on the current shipping version, which is the b26-RF2K Plus. And at Hamvention, at the DX Engineering booth where Chris and Reinhardt were showing the new amplifier, I was there early and actually got a pair of the LD MOS clamps that are on the new amplifier, and they of course will be just a bolt-in replacement for the screws that hold down the LD MOS devices now on the existing shipping amplifier. So that's why I'm making this video. I wanted to just, I mean, it's kind of anecdotal. It's certainly not scientific, but I wanted to see the difference on the heat dissipation and with no drive. So I just did this with no drive. So enough of my video here. Let me make it small here. So what I've got going here, so those clamps, I'm calling them the LD MOS clamps. I don't know if that's the right term for it, but that's what I'm going to call them in the video here. So what I have here is I ran the so the amplifier, this I'm remoted in with VNC right up here. Of course, you've seen this before. And I've got a screenshot right here of my on-screen LP700, the amount of power that the amplifier was driving. This is before I replaced the clamps, so before we all knew about the clamps and the pin-diode, the new amplifier. This is my existing amplifier that I bought in August of last year, so 2018. It was in August, early August 2018. And so here's my not so scientific approach to this. I hooked up dummy load, of course, and on 40 meters, driving it with a K3S, I key the amplifier and turn the drive power down to 0 as far as the K3 is concerned. So there's a little bit, there's obviously some form of RF there because the bias kicks on the amplifier. And so then I just sat here and let that bias heat up the RF deck. And it took a while. I mean, it took me a while. It got up to 48C. You can see in the screenshot here, it finally touched 49C after, I didn't time it. I mean, it took a while. It stayed on 48 for quite a while and then just started touching on 49. And the power output was 27 watts according to my LP700. So the reason I did this is because I wanted to see if those clamps would make any difference on the power output as far as any capacitive coupling or interaction with the LD MOS devices, right? Because they're clamped right on top of them. And hint there, Reinhardt said there was a little bit of coupling going on there, so I expected there to be a slight change. So that's as far as I took it. It was probably, I don't know, 4 minutes, maybe 5 minutes. I got it up to 49C. In fact, so I have since put the clamps on, and I'm going to key up the amplifier, and you're going to see exactly what I did before. So I'll keep the amplifier, and that was like 1 watt drive. And so I just turned the drive down on my K3S to 0. And in fact, if I go to channel 1 that shows the input on the LD or on the LP700, it shows 0 watts drive. And here's the output of the amplifier now is at 28 watts. So you're seeing the heat creep up here a little bit. So it's at 38C, and the power output is at 28 watts right now. And you can see the amp draw according to the, my calibration of the amp meter on the amplifier is below actually 7 amps here. You can see over here in the screenshot, after it got up to 49C, it was still drawing 7.3 amps. So now you can see a little less output, and the corresponding amp draw is surprisingly, less. And the fans just kicked on because we just hit 42C. And while we're letting that go, I have the clamps on now, right? So just to be sure, just making this up as I go. So let me pull up some pictures of the clamps on there, which you guys might like to see, because you'll be able to get these from Reinhardt, potentially along with the new transformer, which is right here. And let me make me even smaller. So here's the clamps. I just took out the stainless steel 3mm. I think they're 3mm bolts. The heads are 2.5 millimeters, I think. But these are the clamps that I brought back from Hamvention with me. And I took the old screws out, and then I just took some denatured alcohol and cleaned off the top of the LD MOS devices and cleaned off the clamps. And then I put them on. And there's been some discussion on the forum about torquing these things down, and I mean, you got to use some common sense here. What I used, and I didn't have them like cranked down ready to break the bolts before. It was easy to just loosen up the bolts that I've had in for months now. I've been running the amp, pretty heavy. I used the amplifier. Just got done with 7QP. It was running for 18 hours straight, that kind of thing, on CW and SSB at 1200 to 1500 watts out. So this is what I use to tighten down the screws, okay? So as you can see in the picture right here, tightening down the screws, I just, I actually put on washers and little lock washers because I had them on hand. So I don't think you're going to get those when you get them from Reinhardt, from RF Kit. But I had some nice stainless washers and little lock washers that I used. So I put the clamps over the LD MOS devices, put the screws in, tightened them down, and then just slowly went back and forth, and got to where I was, just barely moving those screws as much as I could with my hand with this little, hex head driver here. And it's actually made out of plastic, so I mean, I didn't break it, right? I don't think you need to get crazy here. If you're careful and you make it even, I don't think you need to worry about some torque specification, but just don't get crazy, right? You don't want to crush the ceramic or whatever the LD MOS material is there covering up the devices. So that's all I did. So both sides, they're nice and tight there. And I was showing you this thing. Let's go back to the picture here. So here you can see them. I'll just show you some pictures here. It's clean. The machining on the clamps are really nice. I guess we could get some dimensions on it, and guys could make their own. But whoever did the machining for Reinhardt and Chris, or and company, they did a nice job. So here you can get a good shot of these, and I'll post a link to these on my photo gallery too. So there's one. There's the other one closer to the center of the amp. And here you can see the front side. Again, I put on washers and lock washers. Probably overkill. Here's right up against the the current shipping amps transformer there. And this is from the left side of the amplifier, looking in there. And that's it. Those are the pictures I've got, and I'll post those. So anyway, that's been going on while I've been yapping here for a while. We'll make this small again, and you can see it's been on for a while, and it's actually up to 48C. So we're down to 25 watts here. And so just the simple fact of having the LD MOS clamps on there, it's running cooler and it's drawing less amperage. So it may be a function of that more than just the clamps. And again, before I put the clamps on, I couldn't remember how crazy I got on the screws on those previous clamps, because I'm sure I went through and tightened them when I built the, checked them. But I wasn't killing it, right? I don't think we need to strip the screws or break the screws on the LD MOS devices. And the theory, according to Reinhardt, is without the clamps, he was worried, or there was concern that the heat spreader, the bottom metal piece of the LD MOS device was bowing up and maybe not staying in contact with the the main copper heat sink or heat spreader on the RF deck. So so basically what I'm showing you here, it just hit 49. So the temperature is about the same, maybe a little less. One thing that's maybe not comparing apples to apples is I'm gonna not key it, but between when I tested before the clamps were on and after, I really wanted to see how things would go at 1500 watts. So I drove the amplifier up, heated it right up. So I'm going to do this. I probably wouldn't recommend you guys doing this, but I want to show you that we can key this thing down for quite a while at 1500 watts. And I'll do it on 40 meters. All these tests were done on 40 meters, so 7 megahertz. And so just to, it's like impossible for me to keep these videos short. But we're going to key the amp down, so you'll be able to. So that is with. Let's see. Well, I'll show you the drive once I get it up here. So if we go up to 750 watts, well, this is on 7 megahertz. You're going to see the temperature go up. So here we're at 45 C, as you can see. 46, and so it's going to get up into the 50s pretty quick. Let's kick it up to a kilowatt. This is with the clamps. So of course, as the LD MOS devices warm up, right, they're going to lose some efficiency, and so you're going to see the power drop, as you've seen before. So now we're at 50 C, and I'm not timing this, right? So let's just take it right up to 1500 watts. And I'm looking at my K3. I have a 13 dB attenuator, and I'm going to get it right to 13 watts according to the output on the K3. We just kicked into the main amplifier on the K3, and so here I'll just go over 1500 watts a little bit. And then we'll look at the input drive, channel 1. So I'm driving it with 22 watts roughly. So, and it's going to drop there. So here we're at 54 C. Anecdotally, this is doing much better. I mean, you're not going to key the amplifier at 1500 watts this long, right? And 7 megahertz is pretty efficient. It doesn't heat up as much on 7 megahertz. So, right, I mean, I can drive it back up to 1500 watts or a little bit beyond into the dummy load. My dummy load's probably, it's getting warm. It's not like that warm. So here we're at 58 C, and you're not going to use the amplifier like this, right? You're not, unless you're, a heavy RTTY, a really rag chewing kind of a guy. So here we're at 60, and I think I've never taken it up to 70 C, and I think there's protection at 71 or 72 C, if I remember right. So there you go, right? We're pinned right at 1.5 kW plus a little bit more, and we're at 61 C. So let's call that good on 7 megahertz. And now I'm going to, well, we'll take a look here and just let it cool off a little bit. Give you an idea how far it comes down. You should be able to hear the fans too. The amplifier's over here. I think I've got another camera. While that cools down a little bit, let's I think I can turn that on. Yep. So there it is, right there. You can see my hand. The amplifier's right there. And that's my cat in the background there. So I'm going to turn that camera back off. And let's go up to 14 megahertz, 20 meters. So I'll make sure I'm on the dummy load. I'm switched in on the dummy load, not my antenna because it's retracted. And let's key it up. And so you're going to see more heat quicker, right, on 20 meters. So that is, we got 100 watts out with roughly 1 watt of drive with a 13 dB attenuator. And so there I'm back to the output side of the amplifier. On the, you know, we're looking at the LP700, of course. So I'm going to drive it up. So let's get it up to like 750 watts. Right around there. So we're at 53 here, 54. You can tell it's going up a little quicker. Let's take it on up. So now I'm at 13 watts drive roughly, and 22 watts drive. It's similar to what we were seeing on 40 meters. And let's look at the input again, just to. So we're at 21 watts drive on 14 megahertz. And now we're at 62C. So, I mean, it's getting a little hotter. I probably should have done this before I changed or put on the LD MOS clamps, but I didn't. But that gives you an idea for how much legal limit key down time you can get out of it here. Now we're up to 65, right? I'll probably shut her down here pretty quick. 67. So I'm going to shut it down. And there you have it. So there's a video on, you know, very little difference with the clamps. There is some coupling going on there, some interaction with the devices there on the RF drive. It draws a little less amperage at the same watt drive, and you have just a, I mean, it's negligible power difference, a little less power difference. The power output on 40 meters and 20 meters in this case was pretty comparable. And so we dropped down to 57C now, 56, and so it's dropping pretty quick. Anyway, it'll be interesting to see how things go with DX engineering. And, you know, one thing, you know, it's unfortunate, guys, that ordered or just barely got the amplifier, but that's the case with any manufacturer. It's tough to bring out a new product. But, you know, keep in mind you'll have the amplifier, right, until the end of the year when DX engineering starts supplying the amplifiers. A couple things to note on that point. Reinhardt, Chris, they'll be shipping kits to DX engineering, and then the guys in the you know, the service center, the lab at DX engineering, from what I understand, will be assembling the amps, and they'll be selling US dollar prices, assembled and tested and calibrated at $4,900 US. And we don't know what attenuator is going to be on there. I'm guessing it'll probably have a 16 dB attenuator, but you know, as hams, you can change that if you want to lower the, you know, put a different pad in there and have less drive after you get the amplifier. Or you can get the kit for $4,500. So it sounds like they're going to charge $400 US to assemble the amplifier, and you get everything, right? You get the fans, you get the Raspberry Pi. The Arduino isn't in the mix anymore. The pin-diode switching, the redesigned RF deck. You've got a hole underneath the transformer, and so it, you know, Reinhardt, they did a lot of work. Actually, kind of like they had a clear cover over it, which he used when he was testing the airflow to, you know, see how the air was flowing through. I don't know if he pumped, you know, some kind of smoke through there. I don't know. Cigarette smoke? I have no idea. But they did some nice testing. The venting or the cooling's better on the new amplifier. But you can see on the existing amplifier, it works really well for how quiet it is. And, you know, for a typical ham that's contesting with, you know, CW, I'm going to be going full bore this weekend in the CQ WPX, CW. I mean, you're just not going to key the amp up like I just showed you on 40 meters and 20 meters. You're just not going to have key down times like that, right, with CW or RTTY. You know, unless you're sending the ARRL ready bulletins, which I don't think anybody's going to be doing. Reinhardt tells me that the new amplifier will be even better on the cooling. So anyway, we'll leave it at that. I'll put a link to the photos. I've got some pictures from Hamvention too in there that I've already posted on a quick and dirty video I did at the DX Engineering booth. So enough of me, and hope everybody was excited about the announcement at Hamvention, and good luck with your existing shipping b26-RF2K Plus, or if you end up getting the newer model, the RF2K-S or Sierra. 73 guys, NG7M.